Well, it's chilly today. Alright, so this was the first problem here. Cubed root of 9p to the 7th q to the 5th. Okay, so the first couple, what I'll do is I'll write out every little step here, okay? Alright, so we have, since it's a cubed root, we can't simplify the 9, right? Cubed root of 9 can't be simplified. The p can be, right? So if I did p to the 6th, q to the 3rd, times cubed root of 9p q squared, right? So I separated them in so that we could clearly see cubed root of p to the 6th q to the 3rd is equal to p squared q times the cubed root of everything that's left over, 9p q squared, and that's your answer. Alright, for number 2, first we will separate them into radical 5x over radical 8y. And in doing so, we can clearly identify what we need to multiply the denominator to rationalize, right? Okay, so the perfect square the smallest perfect square I see is 16. So I have to multiply the 8y by the square root of 2y, square root of 2y. Now, why do we do that? Because look, what is 8y times 2y? That's 16y squared. That's how we get a perfect square, right? So the numerator, we just multiply the radicands and you get radical 10xy over square root of 16y squared. And then we get 10xy, radical 10xy over 4y, right? We don't have to put the absolute value because they said assume all variables represent positive real numbers. Okay, any questions so far? Alright, let's move on. I'll do square root of square root of 6x times the quantity radical 18x minus radical 2x. So yeah, we can actually multiply this out and then simplify. But I do want to show you the other way that I've been doing it in class. All right, so if you did radical 6x times radical 18x, you do get radical 108x squared, right? And then if you subtract radical 12x squared, you can then simplify, right? So I don't like doing it this way because when you do 6 times 18, it's such a large number, right? So instead of doing that, this is what I'd rather do. So I know that because this is a 6 in the radicand, I see that the 8 is actually 6 times 3, right? So this is a little bit easier in my opinion. So when you multiply, you get radical 6 squared, and then you have your x squared, and then your 3 over here, right? So just by doing it this way, you can see, oh, this simplifies to 6x, radical 3. Much easier than, trying to simplify 108. And then for the second pair, right, when you do radical 6x times radical 2x, you can see that the 6 is actually a 2 times 3. So this is minus radical 2 squared x squared times 3. So this is the same as 2x radical 3. See, much easier in my opinion. I mean, not that 12x squared is hard to simplify, right? Now, the last step, you see that these are like radicals, so you can subtract, right? Radical 3, right? So 6x minus 2x is 4x radical 3. Okay? Alright, let me see for a second here. I need to, okay. Let's continue on. Number 4. This one was pretty simple, right? There's not much to do. This is, you could just, I don't even need to write the radical. We could just jump right into it. Radical 49 is 7. Radical a to the 4th is a squared. That should only take you like 2 seconds. Okay, next is number 5. I see that the denominator, you can simplify really easily, right? Radical 64 is 8. Radical y squared is just y. Nothing else can be simplified, so we're done. Number 6, this is the problem where you multiply, right, by the conjugate of the denominator. So you have to multiply by radical 6 minus radical 3 over radical 6 minus radical 3, right? Okay, so now we can distribute do the distributive property, right? The numerator is a binomial squared, so you could either do it the long way, which is by FOILing, like that, or just do the binomial squared, right? So this becomes 6 and then minus 2 times radical 6 times radical 3 plus 3. Or actually, let me write that over in terms of the formula. Just like that, right? So radical 6 times radical 6 is 6. And then we have this part right here, right? Radical 6 and radical 3 simplify to what? So that's minus 2 times 3 radical 2 plus 3. So 6 plus 3 is equal to 9 minus 6 radical 2. Okay, so that was the numerator. So 9 minus 6 radical 2. Now let's try the denominator. The denominator is a difference of squares. So we have radical 6 plus radical 3 times radical 6 minus radical 3. So the first one is radical 6 squared, and the middle two terms cancel out, right? So we can move on to minus radical 3 squared. So that's simply 6 minus 3 equals 3. Denominator is 3. Now, don't assume we're finished here, right? We have to remember that let me need a little more space here. We have to remember that if there's a common factor that can be factored out and cancel out, we must do that, right? So I see a 3 that can be factored out. 3 times the quantity 3 minus 2 radical 2 over 3. So lastly, the 3's cancel out. So your final answer is just 3 minus 2 radical 2. Does anyone have questions? Okay, so that was the first set, or the first page, rather. Let's see. Here's the second page. Alrighty. Cubed root of negative 27 w to the 6 z to the 9th. So these are all can be done right now, right? So this shouldn't take too long. Cube root of negative 27 is what? Negative 3. Cube root of w to the 6 is w squared, and z to the 3rd. That one's pretty simple. Alright, let's look at the next one. We got cubed root of 4x to the 5th times the cubed root of 8x to the 6. So this one, you can choose to multiply first using the property, right? 4 times 8 is 32, but I already see that this 8 is a perfect cube, right? And the 4 is not. So I might as well just simplify this 8. But before doing that, I want to do the x's. I want to combine the x's because the x's, it's easier to just combine. So if I did cubed root of 8 times x to the, so there are 11 of them, and since it's multiples of 3, I'm going to do x to the 9 times the 4x squared, which is left over. So 8x to the 9th, that's my cube, right? That one can simplify. So we get 2x to the 3rd cubed root of 4x squared. Okay? Let's move on. If you have a question, please type it in chat. Okay, here, let's do this one. I'll use the space above for the work. Okay. Yes, question. Sure. Let me explain that one more time. So, as you can see here, cubed root of 8 is equal to 2, right? 4 is not a cube, perfect cube. So what I'm going to do is I'll combine the x's. If you combine these right now, you get 32x to the 11th, right? Cube root of that. So the x to the 11th, I'm going to separate into x to the 9th and x to the 2nd, or x squared, rather. So 32, instead of separating the 32 right now, I already noticed that the 8 is a perfect cube. So that's why I put it over here. Cube root of 8x to the 9th times the cube root of 4x squared. So now the cube root of 8x to the 9th is 2x cubed, and the remaining you cannot simplify. Does that make sense? Okay. No problem. Alright, moving down to the radical equations. So remember, radical equations, you must check your answers at the end because you may get extraneous solutions, right? Okay, so let's do 13. So first step, let me write the problem down. We have to get the radical by itself. So isolate the radical means you have to add 2 to both sides. Oh, well, this should be a 0. 0. Okay, so we add 2 to both sides. We get radical x minus 7 is equal to 2. Now, we can square both sides. So when you square an entire side like that, the radical will cancel out, and you have just the radicand left over. X minus 7 is equal to 2 squared is 4. Lastly, we add 7 to both sides, so we get x is equal to 11, and check our solution, right? We have to check. If we don't check, we're potentially in big trouble. So here's the check. We got the square root of 11 minus 7 minus 2. Does this equal to 0? So let's see, 11 minus 7, that's our 4. Square root of 4 minus 2 is 2 minus 2 is equal to 0. Very good, it works. So x equals 11 is the solution. Alright, let's do number 14. We got the square root of 3w plus 4 plus w is equal to 8. So we have to isolate the radical, means subtract our w to both sides. So I got the square root of 3w plus 4 is equal to 8 minus w. Now we can square both sides. So let me square the left-hand side, square the right-hand side. Okay, so the left-hand side, it's just a radicand, right? We got 3w plus 4. The right-hand side is a binomial squared. So if you don't recall the formula, right, you have to do it the long way. But if you do remember it, it's the first squared is 64 minus 2 times the first times the second, right? So that's minus 16w, and then plus the last squared. Okay, did you remember what I'm talking about? If you did 8 minus w times 8 minus w, the middle two terms is the same, so that's why it's 2 times the first time the second. Anyway, excuse me. Okay, now I see w squared is positive on the right hand side. Oh, made a mistake there. So I'm going to move these terms to the right. That way 0 is on the left side. So 0 is equal to, so I have to subtract 3w. I'm going to write it from highest to lowest power. So w squared, and then subtract 3w. So that's what? Minus 19w. Subtract 4, and that's plus 60. So now we see a quadratic equation on the right-hand side. So my first, we learned 3 different ways, right, to solve a quadratic. The first way is to factor, second is to complete the square, and the third we learned on Monday, right, which is using the quadratic formula. And we said quadratic formula works for all of them. But this one is actually a problem that's factorable. So factoring is always faster than everything else. So okay, so we got w squared minus 19w. That tells us, okay, it's going to have to be a minus sign. 15 times 4, that's what I just said, yeah. So this is 4 here, and this is 15. Okay, I knew something was wrong there. Alright, w minus 4 is equal to 0. W minus 15 is equal to 0. Therefore, w is equal to 4, or w is equal to 15. Yeah, that one's right. Okay, let's check this. Oh, goodness. Let's check. 4. 3 times 4 plus 4, radical, plus 4 equals 8. So let's see. This is 12 plus 4 is 16. Okay, that makes much more sense. So now I have 4 plus 4 does equal 8. So this is the solution. Alright, let's move on to the 15. 3 times 15 plus 4, and then the radical, and then plus 15 has to somehow equal 8. So this is 45 plus 4 is 49. So radical 49 plus 15, that's 7 plus 15. Alright. So I can already see here that this does not equal 8, right? So w equals 15 is not a solution. We have w equals 4 as our only solution. Okay, so does anyone have questions on number 10? Alright, well, at least the video will be up later today so you can review it yourself. Alright, moving on then. Let's try these. 3 over the cube root of 9x. Now I have to rationalize the denominator. So let me think about what the smallest cube is. And I know that's actually 27, right? 27. So I'm going to multiply this by the cube root of 3 to get 27, and then x squared to get x cubed. So I have to multiply both the numerator and denominator by the same number. And the numerator, we get 3 times the cube root of 3x squared over, and if you can see this is the cube root of 27x cubed. Therefore, this simplifies to what? 3x, right? And the 3's cancel out. So our final answer is the cube root of 3x squared over x. Does everyone understand how to rationalize the denominator for a cube root? Or any root for that matter? Okay, for number 16, 7 and 2. I don't see any perfect squares there. So I can just multiply those, right? So right now I get the square root of 14x to the 7th. And x to the 7th, you can see you can split it up, right, into x to the 6 times x. So that's what I'll do. I'll do square root of x to the 6 times square root of 14x. And this is equal to x cubed times radical 14x. Any questions? All right. Number 17. Cubed root of 54m to the 4th needs to be simplified. So I see the largest cube there is 27. So I'll do 27 m to the 3rd times cube root of 2m. That's my 54m to the 4th, right? And that'll simplify to 3m cubed root of 2m. For the second one, second term, we have there's an 8 in there, right? In the 16, that's my largest perfect cube. So I'll do m times the cubed root of 8 times the cubed root of 2m. So this is equal to 2m. So this is plus 2m cubed root of 2m. And as you can see, these are like radicals, right? Oh, didn't mean to write that there. Like radicals, so you can add 3m and 2m and to get 5m cubed root of 2m. Any questions with that? All right, next one is square root of 3x cubed plus, so the first term, I don't see anything that will simplify. Let me just move this over here. So I'm going to move on to the second term. I see that square root of 75 can be simplified, right? So this is x times the square root of 25 times the square root of 3x. So that's 5x radical 3x. Next term, I see square root of 27x cubed, right? So that's 9 times 3, right? Radical 9x squared times radical 3x. So this is 3x radical 3x, right? So right now we have these three terms. Oh, I should have simplified the first term. I forgot. Hold on. X cubed, I didn't even see that, right? It's x squared times radical 3x. So this is x radical 3x. Alright, so now we see the like radicals. So x plus 5x is 6x, minus 3x is 3x radical 3x. Yeah, it's too early in the morning for this, right? Alright, so we just did the first 2 pages. We have 2 more left. For this page, Forgot to mention to you all, I know I saw you guys do this, but forgot to mention not to do the fractional exponents because it's not relevant to this course. You'll see it in Math 6. So this one, if you struggled through it, I apologize, should have reminded you. So let's just do these three. The square root of, let me zoom in here. Square root of 20 can be simplified, right? We got 4 times 5, so that's 5 times the square root of 4 times radical 5, so that's 2, right? 5 times 2 radical 5 is 10 radical 5. So I'll put 10 radical 5 there. And then for 4 radical 45, we have 4 times radical 9 times radical 5. That's 4 times 3 radical 5, which is 12 radical 5. So this can be rewritten as 10 radical 5 plus 12 radical 5 is equal to 22 radical 5. Okay? Again, if you have questions, type in chat. Let me move down here. Okay. Square root of 32x to the 5th, y to the 7th, z to the 6th. So, if you recall, this is basically just 16 times 2. So I'm going to separate these to radical 16, x to the 4th, y to the 6th, z to the 6th, times the remaining factors, right? That's 2x, y. So the 14 becomes a 4x squared, z cubed, and y cubed, z cubed, and then radical remaining factors, 2xy. Let's do this last one here. Oh, I'm sorry, the last one here. Okay, this is a binomial squared, right? We just did something like that previously. I'll show you both ways for this, but this is like a minus b squared, which is a squared minus 2ab plus b squared, right? So this is a, that's b. So if you follow that, you can do radical 11 squared minus 2 times radical, radical 11 times radical 5 plus radical 5 squared. That's the formula way, right? This is 11 minus 2 radical 55 plus 5. And 11 plus 5 is 16 minus 2 radical 55. That would be our solution. Let's say you did it the other way, which is to distribute. Then you get, the first is radical 11 squared is 11 minus radical 55 minus radical 55 plus 5. So 11 plus 5 is 16 minus, there are two of these, so minus 2 radical 55. So either way you do it, you get the same solution. Okay? Alright, last one. We talked about imaginary numbers, complex numbers, right? And remember, complex numbers need to be written in a plus bi form. So another thing we have to remember is I is equal to square root of negative 1. I squared is equal to negative 1. So as you work through this problem, you'll be using the I squared, right? You don't have to substitute square root of negative 1 with I. It's only when it's a negative radical, that's when you do that, right? Okay, so let's distribute here. Negative 5 times 7 is my negative 35. Negative 5 times negative 6i, that's plus 30i. 3i times 7 is 21i, so plus 21i. And the last term is 3i times negative 6i, which is minus 18i squared. Okay, so like I said, don't substitute I with square root of negative 1. You're substituting negative 1 for I squared though, right? So this is negative 18 times negative 1, right? Which is equal to positive 18. So we have negative 35 plus the positive 18, and then plus 30i plus 21i. So combine the like terms. So if you do the first two, you get negative 17i, and then you do the second two, you get 51i, right? Write the real part first, and then the imaginary part. Any questions? All right. Well, that was it for chapter 7.